All right, guys, so this video is to introduce what it means for shapes to be similar. And I'm going to write down the definition of similar in a second. I just want to show you. So right now you guys are looking at my computer. So this is a circle, obviously. Okay, so if I copy and paste the circle, then these two circles are congruent. Because remember, congruent means they're exactly the same size. Okay. Similar shapes are when the shapes aren't the same size, but they're like just kind of blown up versions of each other. So they're the exact same shape, okay, but they're smaller or bigger, you know, and they can be any kind of, they can be really big or really small or just a little bit bigger or whatever. But the key is that they're still exactly the same. Like they're still both exactly circles. Okay. So I want to show you something. Okay. So, okay. So like if I said that this one had a radius of 3, okay. If this one was twice as big, then this one would have a radius of 6, okay. If it was, you know, 3 times bigger, you know, like if it was like really, oh, that's not what I wanted to do. Sorry, I guess I can't, can I make it bigger on here? I guess I can't make it bigger on here. So anyway, if it was like not quite, you know, twice as big, maybe it would be like 5:3 ratio or something, okay? But the key, let me get out of this, is that it's still a circle. So like if I did anything like this and made it look like ovalish, then all of a sudden they're not similar anymore. Okay. All right. So the next one I have to show you is a rectangle. And a rectangle has 2 dimensions, you know, not just a radius, but this, whoa, what is going on here? Okay, hold on. I'm trying to copy and paste. Hold on a minute. Sorry. Let me get rid of that. For some reason, copy, paste. There we go. Okay. All right. So for this one, when I copy and paste it, of course, it's exactly the same size. It's just a rectangle. Okay. But of course, I can make it smaller or I could make it bigger, but it has to stay proportional. That's the word, proportional. Okay. So for instance, if I did this, let me make it so I can draw on it. Wow, my computer's like tripping up. Okay, hold on. There we go. I think it's actually me, not my computer, but I like to blame it instead. Okay, so what I mean per proportional is like, let's say this was a 2 and I made this one twice as big, so this is a 4. Okay, and then let's say this was an 8. This one has to also be twice as big. So it's not like this side can be twice as big as this side, but this side can be 3 times bigger. It just doesn't work that way. And they're called proportional because if you divide 4 by 2 and 16 by 8, it's both 2. They're both twice as big. Okay, and then of course, since it's a rectangle, this would also be a 2 and an 8, and this would also be a 4 and a 16. Okay, so that's what that means, okay? Okay, I have one more shape for you. Okay, one thing that is also really interesting is that when you, hold on, a minute, so copy and paste, there we go. Okay, so of course these are 2 congruent rectangles, okay, and if you make this one, of course rectangles can be all sorts of different shapes, right? But if I make it just smaller or just bigger, it's going to be similar. And one thing that's kind of interesting is that when you have similar shapes, their angles don't change, even though their side lengths become much bigger or much smaller. Okay, so let me show you what I mean. Hold on. Okay, so like if I had these rectangles, okay, and then let's say I thought this was a 90-degree angle. This one's also a 90-degree angle, right? That's not going to change. And if this was like maybe 25 degrees, this one is still 25 degrees. Okay, and then of course you could figure out this one. This one would be 65, and this one would be 65 because they have to add up to 180. So even though this is a much smaller triangle, the angle measures don't change the same. Or don't change. What will change is the side length. So like if this is 10, okay, and this one's only 8, okay, and then, then there's, the side lengths are smaller, so this would have a ratio of 10 to 8, okay, so that would be proportional in that way, okay. All right, so now I'm gonna walk this camera over to my whiteboard so I can do some problems. So, sorry, you can just, it's a little clunky while I do that. Hold on. Okay. Okay, so what I want you guys to do is go ahead and just take a minute. You can pause the video and write this definition down. Similar shapes have congruent angles and proportional sides. Okay, I want you guys to write that down. And then we're just going to do a couple of examples, okay? All right, so I'm going to draw, first I want you guys to draw a right triangle. Okay, and I want you guys to call that shape A. And then I want you to draw a smaller right triangle that looks like the same shape. And I want you guys to call that shape B. Okay. Similar has a cool little symbol. It's like a crooked thing like that. That means similar. Okay, so if you don't see that symbol, it means that the shapes might not actually be similar. But if you do see it, it means that they are similar. Okay. All right. So this is the questions I'm going to ask you. I'm going to put like a 3 here and a 2 here. So obviously this one's smaller than this one. And I'm going to say, what is the ratio of shape A to shape B? When you do that, you just list A first. So the ratio of A to B would be 3 to 2. Okay. And then I would say, what is the ratio of B to A? And then you would just do it the other way around. You would do 2 to 3. Okay. Easy as that. Okay. All right. Let's do that one more time. Okay. This one, I want you guys to draw a rectangle. Okay, so let's put those right angles on there since it's a rectangle. We're going to call that shape C, and I'm going to put that this is 10 and this is 15. Okay, and then I'm going to put a little similar symbol. Draw a much bigger rectangle. Their angles are still 90 because, of course, the angles won't change. But I'm going to put that this is a 24 now. Okay, and then I'm going to call this shape D. Okay, when I do ratio C to D, the important thing is that you match things up. So there's only one side here. Does that side match more with the 15 or the 10? Okay, and you have to say, well, if that's 24, it's a rectangle, that's also 24. And then this one and this one are both the height. So those would be the ones that would match. So the ratio would be 10 to 24. Okay, but I don't want you to leave things unreduced. I would want you to reduce that and make it 5 to 12. Okay, and then if I said, what is the ratio of D to C, it would just be backward. It'd be 12 to 5. Okay, okay, all right. The last thing I'm going to have you guys do for this homework is I'm just have you draw some things that are similar. So like an example would be, I would say, so I would give you a shape. This is supposed to be a perfect circle. Okay. And I would go like this and I'd put 7 and I'd call this shape E. Okay. And then I would just say, draw a shape. Okay. Similar to E. Okay. In which, okay, the ratio, sorry, my handwriting is really bad. I'm writing on a wall. E to F is 7 to 2. Okay, so draw a shape similar to E, so it has to be similar to E, in which the ratio E to F is 7 to 2. Okay, so I already have E, so if it's going to be similar, it has to be the same shape. Okay, it has to be a circle. And I know it's smaller. This one's called F because it says E to F is 7 to 2. So E to F means this one's E, this one's F. So that means that F is still a circle, but it has to have a radius of 2 to make the ratio 7 to 2. Okay? Okay, let's do one more example. this one says draw a shape. Okay, W, in which the ratio of W to Y is 1 to 4. Okay, and this time I'm going to draw W. Okay, so I'm going to draw a triangle. I'm going to make this 30. I'm going to make this 60. I'm going to make this 2. Okay, all right, and that one I'm calling W. Okay, oh shoot. I'm so sorry, you guys. I should be looking. It says draw a shape W in which the ratio W to Y is 1 to 4. Sorry, I didn't have that up before. Okay, you can just pause it and write it now. Okay, so W to Y, so that means that W is here, Y is here. So Y is 4 times bigger than W. So I'm going to draw a pretty big triangle. Okay, the thing that's not going to change is the angle, so it's still going to be 60. That's still going to be 30. But this side has to be 4 times bigger, so this one's going to be 8. And this is called Y, and because this is a special triangle, we can actually fill all of this in, okay? So, and I'll make sure that I ask for this. If this is 2, and that's the side across from the 30, you guys should know that this is 2 root 3, and this is 4, based on your special triangles, which would make this 8 root 3 and 16. So you can fill in all the sides and all the angles, where this one is the ratio would be 1 to 4 reduced. So 2 to 8 is 1 to 4 reduced, 4 to 16 is 1 to 4 reduced, and 2 root 3 over 8 root 3 is 1 to 4 reduced. Okay, all right, hopefully that was helpful. Just email me if you have any questions. Okay, bye.